Bismillahirrahmanirrahim. Assalamu alaikum students. I hope you are all fine and must be busy with your coursework and with all the other activities of your life. And this is our lecture number 21, and today we will discuss some different topics, that is the assignment methods. Now again, this is a very important topic in operations management, that how we are being able to assign the different jobs to the different persons so that we can complete the jobs within the minimum possible time. So this is the situation which may face in these sort of problems, which may be termed as assignment models or the assignment methods. But before this discussing this particular problem, let's have a review what we discussed in the last class. Students, in the last class we discussed again a very important situation and a special case for the transportation model, that is the maximization. And again, as we discussed, that mostly we are interested in minimization of cost when we are discussing the transportation model, but there may be the certain situations in which we may be interested in the maximization of profit, and we have discussed that sometimes the operations manager may be interested to find out or to maximize the profit margin for the different routes. This profit margin for the similar product may be different from a particular source to the different destinations because of the location advantage or because of the any other advantage which the organization have for a particular route. So in that particular case, we are always interested to maximize our gains, that is the maximization of profit. So we discussed this special case in our last lecture, and again we discussed a different situation, that when demand is greater than supply. So in that particular case, I told you a step which we would have to follow in this particular situation, that is we will have to add a suspicious or fictitious or dummy source of supply, and we'll have to allocate the different quantities equal to the difference of total demand and supply to this dummy source of supply. So in this way we can equate our total demand and total supply. The similar method we adopted for when demand is less than supply, and in that particular case we added a dummy source of demand or the dummy destination when demand is less than supply. So this is the step which is different and which is used to equate the demand and supply. Again, we discussed two important steps which we should have to follow when we are interested in maximization of profit by using that transportation model technique. And we discussed that if we are interested in this maximization problem, what we will do, whenever we will formulate our initial table by using either the northwest method or by using the least cost method, we will have to multiply each of these values which are actually the profit margins by -1. And again, these values are usually, not always, but usually written on the upper right corner of the different cells. So this is the first step, that we will multiply all of these profit margins by -1. And in the next step, when we will calculate the total cost for a particular table, we'll have to multiply that total cost by -1 in order to convert the negative values into the positive values, and these positive values are actually your profit margin or your total profit actually. So these are the two steps which we have followed while we were solving our problem related to maximization and related to the case when demand is greater than supply. And the rest of the steps, students, as you must have seen, that rest of the steps are almost same what we did in minimization problem. So again, we used MODI method, that is to find out the optimal profit in that particular case, And again, in MODI method, we introduce the different variables like u1, u2, u3, v3, v1, v2, and again we formulate the different equations. We put the value of one of the variable to 0, so that we are being able to calculate the values of all the other variables. Now then we use the values of these variables in order to find out the shadow cost for the different unoccupied cells, and then we see that whether this shadow cost is negative or positive for the different cells. If all the shadow cost for the different cells is negative, it means we have achieved our condition of optimality. But if any of the shadow cost for these unoccupied cell is positive, then we'll have to repeat this step, and especially we'll have to find out the particular loop in order to find out the value of theta. So in that particular case, we will find out the value of theta, in which so in that particular case we will find out the value of theta for that particular cell where the shadow cost is highest positive. So after calculating the value of theta, we will incorporate the value of theta for that particular loop, and again we will have to remake this table, and again we will have to find out the total cost. It will be multiplied by -1 to convert into the total profit, until this whole process will be repeated again and again till we achieved some optimal profit. So students, this was a recap what we did in the last class, and I hope you must have practiced this question and also the similar questions from your textbooks. Now come to our today's lecture, that is about the assignment model. As I told you that this is a sort of technique and this is a sort of method in which we are actually interested to make one-to-one assignments. One-to-one assignments means suppose your organization may have the different tasks or jobs, and you want to assign these tasks to or jobs to the different persons. Now this method will guide you that which task is to be assigned to which person, so that your total cost may be minimized. Now again, in this assignment model, we may be interested in minimization as well as maximization. When we talk about the cost or when we talk about the time, we may be interested in the minimization of cost, in minimization of time to be spent for the completion of the different jobs. Maybe we are interested in maximization, that is if we assign a particular job to a particular machine, and if we are able to forecast the profit margin for this particular assignment, then again we may be interested to maximize our profit by assigning the relevant jobs or tasks to the different machines. So students, in these assignment models, we may be interested in maximization and we may also be interested in minimization. Now this method is helpful for different organizations in order to take very important decisions, and again if your organization may have the different tasks which are to be assigned to the different people, this will help us to assign the different tasks to the people so that your total cost or total time may be minimized. Then again, if you have different classrooms available in a particular university and you want to assign the different classes to these classrooms, then again how optimally you can make this assignment, this method will guide you. Again, if there are the different machines in the organization and you want to assign the different jobs to this machine so that the total cost may be minimized or the total time may be minimized, that is the time for the completion of different jobs. So in all of these scenarios, this method, that is the assignment model, will guide you to take very important decisions. So this is our today's topic. Again students, let's have a practical example that a shop has 3 workers and 3 repair projects, and he will have to decide out that which worker to assign to which project. So this is the situation in which we can use this assignment model method, and of course in this particular case our objective may be the minimization of cost in wages to get all the 3 projects done. So again we'll have to find out the assignment of these projects for the different workers, so that our total cost may be minimized. And students, for this particular technique, the method we will follow is the Hungarian method, and we will always try to solve these assignment problems by using Hungarian method. Now Hungarian method is again a sort of algorithm. Algorithm means again a step-by-step approach to be followed in order to achieve our objectives in these sort of situations. So we'll have to follow the different steps in order to achieve our objectives. Again class, in the last 3 to 4 lectures we discussed the different transportation methods, and I have told you, and we have discussed the different steps involved to find out the minimization of cost or the maximization of profit. In the same way, there are the different steps which we will have to follow in that Hungarian method, so that we can find out the optimum assignment of our jobs. Again students, these steps are very important, and again when we will firstly read down these steps, and you may be scared by seeing these steps, but when we will solve the different problems and you have a practice for these steps, then you will start enjoying these problems. Let's discuss first the different steps. Again I will just read out these steps, and again when we will solve a particular problem, then I will tell you in detail that what all these steps are about. So as a very first step, we'll have to convert the practical scenario again in the form of a table. That is, we'll have to list down the different jobs, and again we'll have to list down the different people to which these jobs are to be assigned. And again, if you are interested in the minimization of cost, we will have to allocate the different costs from the particular job for a particular person in the form of a table by taking either the jobs or the tasks in the rows or columns respectively. So after formulating this sort of table, we will start following these particular steps of Hungarian method. In the first step, we'll have to identify the minimum of each row and subtract identified minimum number from each entry of corresponding row. So what we will do in this particular step, we will identify the minimum number in each row, and then we will subtract every number of this row from the relevant minimum number, and this is also known as row operation. And after this row operation, we'll have to recompute our table. Then we will have to follow the next step, that is, we'll have to identify the minimum of each column and subtract the identified minimum number from each entry of the column. So students, in this particular step, what we will do, we will identify the minimum number from each of the column, and then we will subtract all of the different values of the columns from this minimum value of column. So this is our second step, and of course these steps may be followed interchangeably. In the step 3, start from the first row. If there is single row in any row, assign it by scaling and cross all other zeros in the corresponding column. So what we will do in this particular step, we will start from the first row. If there are zeros in this particular row, and if there is a single zero in a particular row, we will have to assign it. Assign means we will scale this particular value, and then we will cross out all the other zeros in the respective column. If initially there are more than one zero in a particular row, we can just leave it and we can move to the next row. Similarly, after completing and after checking all of the rows, we will move towards column. Again, we will start from the first column. We will see that whether there is a single zero in this particular column. If there is a single zero, we will assign it, and we will cross all the other zeros in the respective rows. If there are more than 2 zeros in a particular column, we will initially leave it. So this process will be repeated again and again unless you have crossed out or you have assigned all the zeros in this step. So this step should be continued till all the zeros are either assigned or crossed. If this step don't give the feasible solution, so maybe you got the feasible solution after you assign a particular job to a particular person. So again we'll have to assign each and every job to any of the person. So that may give you the optimal solution. But if this step don't give the feasible solution, that is all the jobs are not being assigned to the different persons, then we will have to go to the step 4. Step 4 further have 5 steps, and again we'll have to follow these sub-steps very carefully and sequence wise. And again class, these steps are not written in most of the books, and I have listed down these important steps for you students. If you follow these sort of steps in order to solve the assignment problems, you may not feel any problem or any confusion. But if you use the different hypothetical methods as discussed in some of the books, then you may feel problem and confusion that how to find out the optimal solution in these sort of problems. So I recommend you always to be very careful while using these steps, and you should always remind all of these steps very carefully and very sharply as well. The first step is take an unassigned row. Now after completing the first, second and third step, we will see that whether there is an unassigned row, we will if there is an unassigned row, we will tick down that particular row. If there are more than 2 rows which are unassigned, we will tick all of these unassigned rows. Then we will check whether these ticked rows have any 0, then tick the corresponding column. If these ticked rows have any zeros, then we will tick the corresponding columns. Then again, if the ticked columns have an assignment, then tick the corresponding row. If these ticked columns have any assignment, we will tick again the corresponding rows. So this is a 3-way step, and again you may be feeling confusion when you read down these steps at this stage, but when we'll solve the problem, I will tell you and I will explain you each of these steps while solving the related problem. We will repeat the steps 2 and 3 till no more ticking is possible, and after this ticking, what we will do, we will draw the lines through an unticked rows. We will find out that what are the rows which are being unticked. We will draw the line on whole of this row, and the ticked columns, again vertically we will draw the line for these ticked columns. The number of lines which we have drawn after following these 2 particular steps, these number of lines will represent the maximum number of assignments possible. So if we draw 3 lines, it means we will be able to assign the 3 particular jobs. But we are always interested to assign all of the jobs to the relevant persons. So again class, after step 4 we will go to the step 5, that is after all these lines we will find out the smallest number through which line is not passed. There will be many rows and columns through which the line will be passed, but they may be the numbers through which line is not passed. Out of those numbers we will find out the smallest number, and we will add this smallest number to the number at the intersection of the lines of rows and columns. The points or the cells where the lines are being intersecting for the different rows and columns, for those points of intersection we will add the particular smallest number which being computed in this particular step, and then we will subtract this number from all those numbers through which line is not passing. So all those numbers through which line is not passing, we will subtract this smallest number, and the rest numbers will remain same, that is through which a line is passed, but that is not the point of intersection actually. So those numbers will remain same. Then we will move to the step number 6, that is again we'll have to go to the step number 3 if you are not being able to find the optimal solution. Now the optimal assignment can be made by putting the square on the 0 entry of the assigned job, which will have no alternatives. Now maybe after doing all of these steps you may have an optimal assignment. If the optimal assignment is still not possible, repeat this process, that is step 3 to 6, in similar way until all the jobs are assigned. Now when we will be able to assign the different jobs, what we will do, we will calculate the total cost if we are interested in minimization by referring these finally assigned zeros to the original payoff matrix. So this final matrix or table will guide you that how to assign the different jobs to the different people, and again what is the total cost for the different assignments, and we'll have to refer to our original table in which the cost from the different people to the different task is being given. We'll have to refer that table to find out the total cost. So students, these are the different steps which we'll have to follow for solving the problems related to assignment method. Now this is an example of assignment model. Now suppose there are 4 machines, that is M1, M2, M3 and M4, which is represented in the form of a column, and there are 4 jobs, that is J1, J2, J3, J4, and assigning a particular job to a particular machine has a particular cost which is being represented by this C11, C12 and so on. So C12 is actually the cost beared by assigning the job J2 to the particular machine M1. Similarly, C44 is the cost by assigning the job J4 to the particular machine M4. So this is the table which we will have to use to find out the optimal assignment, so that we can assign each of the job to any of these persons. And again, there is an assumption in this particular method. We can assign only one job to one person. We cannot assign one job to different machines, or one machine cannot be assigned the different jobs as well. So this assumption you should always keep in mind while solving these assignment problems. So class, at the end, again we will be interested to find out a sort of assignment through which we will be able to minimize our total cost. So these are the machines, these are the different costs given in the form of table, and these are the different jobs. Now let's students discuss different examples that how we will be able to follow those steps which I have just read out in order to find out the optimal assignment for these problems. Students, this is a problem that is we have four machines, that is M1, M2, M3, M4. There are 4 jobs, that is J1, J2, J3 and J4, and per unit cost is being given in this form of this table. That is, we'll have to bear $15 if we want to assign job J1 to machine M1, $13 if we want to assign J2, that is job 2, to machine M1. Similarly, the different costs for assigning the different jobs to the different machines are given in this form of table. And what is being required, we'll have to find out that which job is to be assigned to any one machine to get the minimum cost. So this is basically an assignment problem. And next, now we will have to solve this problem. Now students, let me draw this table. Now students, we have 4 machines, that is M1, M2, M3, M4 and we have 4 jobs as well, that is J1, J2, J3, J4, and the cost for assigning these jobs to the relevant machines is also being given in the table, that is 15, 13, 14, 17, 11, 12, 15, 13, 13, 12, 10, 11, 15, 17, 14, 16. So I have just redraw this table. Now class, if you remember the steps which we will have to follow for solving this assignment problem, the first step is related to row operation. Row operation means we will have to find out the minimum value out of each row. So in this particular row, what is the minimum value? This is 13. 13 is the minimum value from this first row. So let me write this minimum value here, 13. In this particular row, the minimum value is 11. So let me write this value here. Out of this row, the minimum value is 10. So let's write here. And out of this row, the minimum value is 14. So we have identified the minimum value out of each of the row. And what we will do in the row operation, we will just subtract this minimum value out of all the relevant values from a particular row. So let's redraw this table. So again class, this is M1, M2, M3, M4, this is J1, J2, J3, J4. Now what we will do, we will subtract this minimum value from each row. So in the first cell it will become 15 minus 13, that is 2, 13 minus 13, 0, 14 minus 13, 1, 17 minus 13, 4. Similarly, we will subtract the smallest number, that is 11, from the second row. 11 minus 11, 0, 12 minus 11, 1, 15 minus 11, 4, 13 minus 11, 2, 13 minus 10, 3, third row. 12 minus 10, 2, 10 minus 10, 0, 11 minus 10, 1, then 15 minus 14, this will become 1, 17 minus 14, this will be 3, 14 minus 14, 0, 16 minus 14, 2. So class, we have just followed the first step of Hungarian method. What we did, we find out the minimum value out of each row, and then we subtract all the values of the respective rows. Then we subtract this minimum row value from all the values of the respective rows. So we have this particular column. So we have this particular table. So in the next step, what we will do, we will follow the column operation. And what is the column operation? Again, in this particular table, we will find out the minimum value for each column. Let me write this minimum value here. The minimum value in this particular column is 0. The minimum value in this particular column is again 0. Again, the minimum value in this particular column is 0. In this particular column, the minimum value is 1. So what we will do in the next step, we will subtract all these minimum values from each number in a particular column. So this is the column operation. We will do this operation column wise. So class, let me redraw this table again. So class, this is our previous table. Now we'll have to do the column operation. What we will do, we will subtract the minimum column value from each column. So this is the column operation. Now if we subtract 0 from the first column, the column will remain same, that is 2031. 2031. In next second column, the minimum value is again 0. So if we subtract 0 from the different numbers, it will remain same, that is 0, 1, 2, 3. 0, 1, 2, 3. Similarly, in third column, the minimum value is 0. Again, this column will remain same, that is 1400. 1400. Then class, in fourth column, the minimum value is 1. So we will subtract 1 from all of the values in this particular column. So 4 minus 1 will become 3, 2 minus 1 will become 1. 1 minus 1 will become 0, 2 minus 1 will become 1. So this column will become 3, 1, 0, 1. 3, 1, 0, 1. So class, what we have done two different steps, that is step 1 row operation, step 2 column operation. Now we'll have to follow the step 3. Now what is the step 3? You must have remembered that I told you that we will start from the first row. Now this is our first row. If there is a single 0 in this particular row, what we will do, we will assign that particular 0. As you can see that this is our first row and there is a single 0 in that row. As there is a single 0 in this particular row, so we'll have to assign this 0 and we can place a sort of square in this particular 0. This square means that this 0 has been assigned. So move to the, now again, if this 0 column has any other 0, we will cross those zeros. As you can see that there is no other 0 in this particular column, so we will remain it unchanged. Now again, go to the second row. The second row is also having 1 0. Whenever there is a 0 in any row, we will assign it. Assign means we will make a square around that 0, and again we will have the we'll have to see the other entries in the relevant column. If there is another 0 in the relevant column, we will have to cross it. Now this is very important, but again in this particular column there is no other 0, so we will remain these values unchanged. Again we will move to the third row. In this row you can see that there are 2 zeros. So if you see the steps I told you in order to solve these problems, it is being told you that if there are 2 zeros in any row, when you are going to start from the rows, then we will just leave it initially. As there are 2 zeros in this particular row, so we will leave this row. Now again class, let's move to the fourth row. There is a single row. Now students, again let's move to the fourth row. In this fourth row there is a single 0, so we will assign this single 0 by making a square around it. And again you'll have to see the relevant column. This is the relevant column, and I told you if there is any other 0 in the relevant column, what we will do, we will place a cross around that 0. So this is very important. Now we have completed the operation row wise. Now we will start from the column wise. Now again let's start from the first column. Now this column has 0 which is already assigned, so we will leave this column. Again we will move to the next column. There is a single 0 which is already being assigned, so we cannot assign any other 0, and there is no more 0 in this particular column. We will move to the third column. There are two zeros, one is already crossed and the other is already assigned, so again we will leave this column as it is. We will move to the fourth column. Now you can see that there is a single 0 in a column, so we will assign this 0, and then we will also see the relevant rows. If there is any other 0 in the relevant row, we will have to cross that 0. There is another 0 but that has already been crossed. अगर इस रो में कोई और भी 0 होता तो हम उसको भी क्रॉस कर देते. Now this is very important class. Now again I am repeating this particular step. We will start from the first row. If there is a single 0 in a particular row, we will assign it by scaling, and then we will see the relevant column. If there is any other 0 in the relevant column, we will cross it. Similarly, we will move to the second row. Similarly to the third row, if there are two zeros in any row, we will just leave it initially, and we will move to the next row. Again, if there is a single 0, we will have to make a square, and we will have to cross down all the other zeros in the relevant column. So this row operation is completed. Then we will move column wise. If there is any other 0 which is not being assigned or not being crossed, we will assign it if there is a single 0. If there are two zeros in a column, we will leave it. So that's why we check this particular column. This 0 was already assigned, so we move to the next column, already assigned. Third column, already assigned, already crossed, zeros. Then we move to the fourth column. There was a single 0, so we make square or we assigned it, and all the other zeros, if there is, we will cross it. In this case there was a 0 but that was already been crossed. So this is the end of step number 3 class. Now you can see that there are 4 squares in this table, and this shows us that we can make the optimal assignment in this particular case. Now how we will make the assignment? You can see the first 0 which is being squared. That it means that we will have to assign the job 2 to M1. Now this assignment is very important class. Please note down that we will have to assign machine 1 the job 2. Now how it is being stated? Because of that assigned 0. This shows that this particular machine should be assigned this particular job. Similarly, next square or 0, M2 should be assigned job 1. M2 should be assigned job 1. Similarly, this particular 0 or assignment, that is M3, should be assigned J4. M3 should be assigned J4, and similarly this assignment, that is M4, should be assigned J3. M4 should be assigned the job J3. Now class, we didn't follow all of these steps because we have our optimal solution after the step number 3. If we are not being able to achieve all of the assignments, and then we'll have to move to the next step. Suppose we didn't get the 4 assignments here in this particular step, and we may get 3 assignments or 2 squares, then we'll have to move to the next step. But in this particular case, we have achieved the optimal assignments, that is 1 assignment for the different job. There are 4 assignments which have to be allocated to the 4 machines. So we have already achieved the optimal solution in this particular case. Now we'll have to find out what is the minimum cost. In order to find out the minimum cost, we'll have to again refer to our original table. Now what is our original table, class? This is our original table. Now we will see the relevant assignment and we will compare it with this table. That is, we are assigning M1 to J2, M1 to J2, and the cost from M1 to J2 is 13. So we will write 13 here, that is $13. Similarly, if we assign M2 to J1, we will compare it to the original table M2 to J1. Now if we assign M2 to J1, the cost is $11, so we will write $11 here. Similarly, we will compare M3 to J4. M3 to J4, the relevant cost is $11, so it will become $11. And again M4 to J3, we will refer to the original table. M4 to J3, the relevant cost is $14. The relevant cost is $14. Now if we add up this particular cost, this will become 314,549, 1234, $49. So class, after following that Hungarian method, we are able to achieve the optimum assignment. That is, we have to assign the job 2 to machine 1, and its cost will be $13. J1 to machine 2, $11. J4 to machine 3, $11. J3 to M4, $14, and the total cost will be $49, which is actually the minimum cost. So this is the way how we can find out the assignments for the different machines in this particular case. And now you are being well aware of that how we can use those steps of Hungarian method. Now students, let's discuss another problem. Now again, suppose there are 3 projects, P1, P2, P3, and we'll have to assign these projects to the different persons A, B and C. The different cost for assigning a particular project to a particular person is given in this table. That is, $11 is the cost for assigning the project P1 to the person A, $14 is the cost for assigning project P2 to the person A. Similarly, the cost for assigning the different projects to the other persons is given, and what is being required, we'll have to find out that which project is to be assigned to which person to get the minimum cost. Again, this is the assignment problem, and we will follow the similar method again. Let me again draw this particular table. Now again class, these are the different projects P1, P2, P3, and these are the different persons, that is A, B and C, and the relevant cost is already given to you: 14, 6, 8, 10, 11, 9, 12 and 7. Now class, we have made this table. Now what we will do, we will have to apply the row operation first. That is, find out the minimum value out of each row. Now out of this row, the minimum value is 6, so I am writing this 6 here. The minimum value from this row is 8, so I am writing 8 here. The minimum value is 7, so I am writing 7 here. Now what we will do, we will subtract this minimum value from each of these relevant row. So let's do this row operation. So class, 11 minus 6, it will become 5. 14 minus 6, it will become 8. 6 minus 6 will become 0. Similarly, from the second row, 8 minus 8, we are subtracting the minimum value out of each row. That is, 8 minus 8 will become 0. 10 minus 8 will become 2. 11 minus 8 will become 3. 9 minus 7, 2. 12 minus 7, 5. And 7 minus 7, 0. Now this is our row operation. Now class, in the next step, we'll have to find out the minimum value from each column, and again we'll subtract all of these values of columns by this minimum value. Minimum value from the first column of this table is 0. Minimum value in the second column is 2. The minimum value in the third column is 0. So in the next step we'll have to subtract all of these minimum values from the relevant columns. So let me draw this table again. This is our column operation. That is the step 2 of Hungarian method. Now class, in the first column the minimum value is 0, so if it subtract 0 the column will remain unchanged. That will become again 502. 502. In the second column the minimum value is 2. If we subtract 2, 8 minus 2, 6, 2 minus 2, 0, 5 minus 2, 3. So it will become 603. 603. Now again in third column the minimum value is 0. So our third column will remain same, that is 030. 0, 3 and 0. So class, now we will again follow the similar step, that is the step number 3, that we will have to start from the first row. Now this is our first row. Now you can see there is a single 0 in this first row. Now what we will do, we will just scare or we will just assign this particular 0. So we will make a square around, it means we have assigned it. There is a single 0. Now after assigning it, we will have to see the relevant column. Now this is the relevant column for this assignment. If there is any other 0 in this column, we will have to cross that 0. Now what is the reason of this crossing? Because we cannot assign a single project to the 2 persons. That's why we are crossing the other zeros. And again, in this method, 0 always helps you to assign the different projects to the different persons. So again, class, let's move to the next row. In second row, in next row or second row, you can see there are 2 zeros. Whenever there are 2 zeros, you can always leave it. So we will leave initially this particular row. Now let's move to the third row. Again, in the third row, you can see that there is no other 0 remaining. There is a 0 which is already been crossed. Now again, we will start this operation column wise. This is first column. In this column, there is a single 0. So what we will do, we will assign this 0 by scaling, and we will see the relevant row. So this is the relevant row. If there is any other 0 in the corresponding row, we will cross that particular 0. So after this row 1, we will move to the row 2. You can see in the row 2 there is no 0. There is a 0 which has already been crossed. So we will move to the row 3. In row 3 you can see there is 0 which is already assigned. There is another 0 which is already crossed. So this is the end of our step number 3 actually. And after this step, all the zeros should either be assigned or should either be crossed. You can see that all the 0 या तो हमने assign कर दिए हैं by scaling, या हमने इसको क्रॉस कर दिया. There is no other 0. अगर कोई भी other 0 होता है इसमें, तो इसी ऑपरेशन को हम दोबारा रो वाइज स्टार्ट कर देते. Now this is very important. Now we cannot get the optimal assignment in this particular case. As you can see that there are 2 squares. It means we can make the 2 assignments out of this table. So in this particular case, class, we'll have to move to the next step. Now what is the next step, class? Now we will have to tick an unassigned row. Now you can see this row, this is assigned row because there is an assignment in this row. Second row is also the assigned row because there is assignment in this row. Now this is the unassigned row in which there is no assignment or there is no square we have made. So we will just tick down this particular row. if the ticked row, now this is the ticked row, if the ticked row has any 0, now this ticked row has this 0 at this place, we will tick the corresponding column. Now these are the steps we were talking about. Again, first see the row which is not assigned. This is the row which is not assigned, so we just ticked it. If an assigned row has a 0, इधर क्योंकि ये 0 आ रहा था, इस वजह से corresponding column को आपने टिक कर देना है. अगर एक से ज़्यादा जगह 0 आ रहा होता तो उसके कॉलम को भी हम टिक कर देते. So if the ticked row has the 0, we will tick the corresponding column. Now third step, sub step actually, if the ticked column has an assignment, now this is having an assignment, we will tick the corresponding row. Now this step is very important, class. Again I am repeating, we will tick down the rows which have no assignment. If the ticked row has a 0, we will tick the corresponding column. Now third step, if the ticked column has an assignment, we will tick the corresponding row. So in this way we are going to complete this step. Now class, we will move to the next step. What is the next step? We will have to draw the line on the unticked row and the ticked columns. Now this is the unticked row because all the other rows are ticked. So class, what we will do, we will draw a line on this particular row which is the unticked row and the ticked column. Now this is the ticked column. Now again we will draw the line on the unticked row and the ticked column. Now again what we will do, we will find out those numbers which are not being lined. You can see that 5, 6, 2 and 3, these are the 4 numbers जिधर से आपकी line नहीं गुजर रही. Now we will find out the minimum number out of these unlined values. You can see that out of 2, 3, 5 and 6, the minimum value is 2. So let me write here, the minimum value is 2. Now what we will do, we will find out the cells where this row and column are intersecting with each other. So we will add this minimum value at that particular step. But for that particular step, let me redraw this table. Now class, the minimum number we have found is 2. Now what we will do, now this is the point where the line and the line of row and the line of column are intersecting with each other. So what we will do, at this particular place we will add that number, so it will become 3 plus 2, that is 5. बाकी numbers जिधर से line गुजर रही है वो आपके same रहेंगे. So this will remain same, this will remain same, this particular number will remain same, this particular number will remain same. Now the numbers जिधर से line नहीं गुजर रही उनमें से हम क्या करेंगे, इस minimum value को minus कर देंगे. So 5 minus 2 will become 3, 6 minus 2 will become 4, 2 minus 2 will become 0 and 3 minus 2 will become 1. So class, again I am repeating that after drawing those lines we will find out the minimum number through which line is not passed. 4 ऐसे नंबर थे, 5, 6, 2 और 3, इनमें से जो minimum value है that is 2. So we will subtract this 2 out of these numbers जिधर से line नहीं गुजर रही. So that's why we subtract this 2 from 5, 5 minus 2 3, 6 minus 2 4, 2 minus 2 0 and 3 minus 2 1. इस नंबर को उस सेल में हमने ऐड करना है जिधर दोनों जो आपकी रो और कॉलम वाली लाइन है वो इंटरसेक्ट कर रही है. Now this is the cell where this line and the vertical line intersect with each other. So we add this number, 2 plus 3 will become 5. बाकी सारी जो वैल्यूज हैं वो सेम रहेंगी, जिधर सिर्फ लाइन क्रॉस कर रही है लेकिन वो इंटरसेक्ट नहीं कर रही. Now this number 0 will remain same, this 0 will remain same, this 0 and 0 will remain same. Now class, again we'll have to repeat that step, that we'll have to again start from the first row. That is, this is the first row. You can see that there is a single 0 in this particular row, so you can assign this 0 by scaling it. Now again this 0 has this 0 in the respective column, so we will cross this particular 0. Again I repeat, this row has a single 0, we scale it and we crossed all the other 0 in the respective column. Similarly go to the row 2, there are 2 zeros in this particular row, so initially we will leave it, we will move to row 3. This is row 3, there is a single 0 in this particular row because the other 0 is already crossed, so we can assign it and we can again make a scale around it. So again students, when we will make the assignment at this particular cell, we will have to cross the relevant zeros in the respective columns. So we will have to cross this particular 0. Now start from the column wise. Now in this column there is no 0 which is unassigned or crossed, so we will leave this column. In this particular column, second column, there is a single 0 which is not assigned, so we can assign it and again we can cross the relevant zeros in the rows. It is already been crossed, so again third column already assigned and already crossed. So this is the completion of this step, and now you can see that we can make the optimal assignments because there are 3 assignments in this particular case. And what is the optimal assignment? We can assign project 3 to person A1, we can assign project P2 to person B, and we can assign project P1 to person C. So our cost will be minimized because we have the optimal assignment in this particular case. Now what is the minimum cost? Again, to find out the minimum cost, we will have to refer to the original table A1 to P3. In the original table, if you see that A to P3 the cost is 6, so we will write 6 here, $6. Then again B to P2, the cost is $10, so let's write $10 here. And again C to P1, the cost is $9, so we will write $9 here. And our minimum cost in this particular case is 10 plus 6, that is 16, plus 9, $25. So in this way, by following the different steps of Hungarian method, we will be able to find out the minimum cost by making the optimal assignments. So this is all about the assignment problems class. In the next class, we will discuss the further problems and we will solve the different other problems related to that assignment model. I hope you will go through this lecture very carefully, and because these steps are very important, just read down the steps of Hungarian method because in the next lecture we will have to do some more problems, and if you are being able to remind all of these steps, then it will be always easy for you to solve the related problems. So it's all for our today's lecture. I wish you good luck, students. Be happy. Khuda Hafiz.